I am in the middle of working on this Lightning McQueen, and I have the wire harness out of the car, and I want to take this opportunity to show how to wire one of these up. So this is a stock Power Wheels wire harness. The only thing that isn't original is the previous owner had taken out one of the switches, so this just switches direction, forward and reverse. There's no high-low, forward and reverse. So there's only two positions. You can see in here, no second switch. So that's fine. This will be good enough as a demonstration. So I have my meter here. I have a DeWalt battery hooked up to the harness, and I want to show where you should get voltage and when on this wire harness. And then we're going to connect it to the Speedy Squirrel speed controller in the most common configurations and kind of show you some troubleshooting methods and how to get that wired up. So when you do this, keep your wire pairs together. So orange and blue, black and red. And you can see these are the two motors. So this motor is pretty seized up. This motor's good. So I'll do some testing with this motor just to show it working once I get stuff going. Once I get it hooked up to the speed controller, I'll show it. All right, so white and black. White is red, black is black. So white is positive in the Power Wheels wire harness. Not all cars and DC systems, it's not necessarily a standard. White is sometimes neutral. Well, white is neutral in house wiring, so it is common that you will see white as the negative or ground, and the black will be the positive. That is common. I've seen it in some cars. I can't remember which one. So keep that in mind. But in Power Wheels, white is positive, black is negative. So you'll see on the back of the pedal, there are three. So that's the first thing. White comes into the bottom pin on the pedal, and then middle pin goes out as red, indicating you're positive, and then orange, that's indicating your brake loop. So when this is released, there's continuity from this middle to orange, and then when you press it, there's continuity from white to red. So I can show you here on the meter. White, I'm going to get 20 volts. On red, I get 0, and orange, I get 0. So now I'm going to press the pedal. I'm going to still have 20 on white. I'm going to see 20 on red, the middle pin, and I'm going to see 0 on, roughly 0 on the orange. That's millivolts if you can't read the unit, so that's essentially 0 volts. So pressing this pedal is going to connect white to red, and that's going to send the voltage to the direction switches. Now, unfortunately, I don't have a complete wire harness out of a car, so this is very similar to what you see, but usually there's another switch here, and one of the switches switches the direction, and then the second switch switches if the motors are wired in parallel or series. So if the motors are wired in parallel, then you have high. If they're wired in series, you have low. In parallel, you're putting the full voltage, in this case 20 volts across both motors. In series, it's split in half, so you're only going to put half. And then I'm assuming the motors are identical, which they're not always. That's why sometimes one motor spins faster than the other, stuff like that when you're in low. So when you're in low, these are wired in series, so you get half the voltage across each motor. So you'll get 10 volts per motor with a 20 volt input. Okay, so with the pedal released, you're not going to get any voltage out. But once I press it, we're going to, on one of these wires, I gotta find which one, must be in reverse. So there we go. Now we have 20 volts when we press the pedal. And so that was black wire, had 20 volts. Now if we flip this gear selector and check red, there we go. And we have 20 volts again. So that's the very basic wiring of a stock harness. Now, what we're going to do is disconnect our battery before we short something out. What we want to do is we want to take this wire harness and connect it to this speed controller. Now this speed controller has two motor outputs, A and B, and a plus and minus for the battery inputs. So the battery is going to come straight into this, not through any of this harness, and the motors are going to go out straight to the motors and not go through any of this wire harness. So this wire harness is only going to be for the logic signals to detect if you are in forward high, forward low, reverse, and if you have a throttle, you can wire in a throttle pedal, or you can use it as a soft start module. It's up to you. So the first failure when modifying Power Wheels is you put a drill battery in it and run the stock motors. This stock motor ran for about a day and it seized up. And that's all we did was run either DeWalt or rigid 20-volt batteries. No, I have a 20-volt, 60-volt flex battery, but it's wired for 20 volts in this adapter. So I'm running 20 volts even though it is a 20 or 60-volt battery. So these do fail pretty quickly. So that's kind of the first failure. So then you're going to go and put bigger motors in it. Well, the bigger motors are going to draw more power. More power means higher current if you're keeping voltage constant. And that higher current is going to be more demanding on the contacts in these switches. So the plunger switch and the direction switches. So contacts are rated for a certain switching power with limits on current and voltage. So these are 12-volt switches, and they're rated for a certain current. Let me read it real quick and see if I can figure out what it's actually rated for. Okay, so this switch is rated for 12 volts at 30 amps. What that really means is at 12 volts, 30 amps, this switch is going to last a X number of cycles. So you're going to be able to break and make 12 amps, 12 volts at 30 amps a certain number of times. Usually that's going to be in the 1 to 10 million range for most high quality contacts. Now, increasing that voltage to 20 and increasing that current to about 40 amps, which is what you do. You bump up the voltage, you're also increasing the current. So you're going to be roughly 40 amps for two stock motors at 20 volts. That's a huge increase beyond what this switch is rated for. And even though it might be a million cycles at 12 volts at 30 amps, once you go to 20 volts, 40 amps, that's going to be less than 100,000. It degrades very quickly once you go above that. The contacts you wear when you're making and breaking, the wear at constant current of just you push the pedal and leave it, that's pretty negligible unless you're putting a lot of current, a lot higher than the rating. So when you're making the contact, the inrush current is damaging the contact. When you break the contact, the current flowing through it, you have to break. You're driving motors. These are an inductive load. That current doesn't want to stop immediately. So that current's going to keep flowing even though the gap between those contacts is growing larger and larger. And the larger that gap, the higher the resistance is, the higher the peak voltage. So even though it's 20 volts, that current that's being forced through those contacts is going to be 1,000 volts maybe. It's probably an exaggeration, but it will be significantly higher. Plunger switch, big failure point once you increase the current and voltage. And then the second failure point is this switch. This is 14 gauge wiring. That's fine. I mean, you're pushing the limits of 14 gauge wiring with just by bumping up this battery to a 20 volt battery and running stock motors. And then of course, once you go to a 775, you're really pushing the limits of what this wire is designed for. Typically you see plunger switch and direction switches failing before you really run into any wiring issues, but I have had a few cars have pretty melted wires before we developed this motor controller. Okay. So now how do we connect it? So this is easy. Plus and minus, no brainer. A and B, no brainer for the motors. Now, if you're in forward and one of the motors is spinning in reverse, you're just going to switch the polarity on that motor output. That'll solve your problem. Now, how do we wire this thing? How do we make it so all we have to do is plug in the stock wiring harness and make this thing work? Well, what we have on the control is we have a 12 volt output. So you can feed this up to 40 volts, 10 to 40 volts, and you're gonna get 12 volts out here. So we can take the original wires and plug those in. So white into plus 12, black into B negative. This is 14 gauge, so I strip it down to like 16. I use the 16 gauge stripper to get rid of some of those strands to get that to fit into this terminal block. I went with a pretty small terminal block to get more options of I/O in a smaller package. Now, you want to be very careful not to have any stray wire strands sticking out when you're doing this and shorting anything. Now you want these to be pretty tight, but it is a spring. You're screwing a spring down, so that spring holds tension, and I haven't had any issue with these loosening up or backing out. So I have plus 12 and B negative connected. Now, we have these 4 wire connections. Now, this switch, ignore the fact that it just is switching forward and reverse, normally is switching polarity on the motors and switching them from parallel and series. Now, we have a circuit in here using the L plus L minus L plus R minus R, and by plugging these in the right orientation, which I just can't tell you which, unfortunately I don't know, orange and blue versus red and black, which one to plug into where, but you do have to keep these together and keep these together, and you're going to connect those 4, and it's going to be able to detect forward high, forward low, and reverse. Since I don't have forward low, I only have to connect 2 of them. So, and the 2 are going to be the left plus and left minus. So let me hook those up. Actually, I'm going to use these because I already figured out which way was forward and reverse. So if I plug in the red to left plus and the black to left minus, when I turn this on, I should be able to get direction when I push this plunger switch in. Now, let's hook up a battery. So red goes to plus. Please try very hard to not connect this incorrectly for the battery polarity. Try not to connect anything incorrectly. Not everything has protection, so this does not have reverse polarity protection. You should just blow a fuse and it should work fine if you do connect it incorrectly, but there have been a couple failures from people plugging them in reverse polarity. Okay, now plug in the battery. Should get this red LED. That means everything is booted and it is enabled. Once it's booted up, we're going to take our phone. Anything with Wi-Fi, you're going to find the network speed control. You're going to click it, and it's going to ask you for a password, and you're going to connect with the password speed control. Once you're connected, you're going to go to any web browser. You're going to type in 4.3.2.1 in the search bar. It has to be the web address bar. If you search 4.3.2.1, it's not going to work. So make sure it's the web address bar or search bar. It's actually trying to go to an actual web address. And this is the home page. So speed control, it's got the software version. You can set a bunch of parameters. What we're interested in is we have the correct voltage, 20.52 volts. We checked that with the meter earlier. And then when we press this, we get forward high, and we switch it, and we get reverse. And that's it. This thing, let me hook up a motor. Remember to disconnect your battery before you change any wiring. Sometimes I forget myself. All right, I'm gonna hook up a battery and I'm gonna push the pedal and it's not gonna work. Now, it's not gonna work because I haven't figured setting it up yet. See, nothing. So I'm gonna log back in. All right, we're back in. So it comes default with the throttle pedal enabled. The reason for that is if the throttle pedal is disabled, as soon as it gets a direction input, it's going to go. So I don't want people to hook it up, planning to use a throttle pedal, do the next step where they short the white to the red on the plunger switch, have a direction, power it up, car drives off. So it's going to come with throttle pedal disabled or enabled. You're going to go down and click submit. And when I push this, that motor is going to go full speed. So there's a minor ramp up and ramp down time, so it doesn't jerk too much. But there we go. So we can set a limit here. Oh, it's actually in reverse, isn't it? So so we can turn that way down. So this is the way that I often break in motors, is I find a limit that seems good. There we go. And I let it run for 10, 20 minutes, whatever's needed to get those brushes broken. And I'm gonna reset to default and I'll be right back. I'm gonna go get a variable pedal. We're gonna run a variable pedal in that car. So I'm gonna show you how to install a variable pedal too. I grabbed a pedal adapter. If you're buying a pedal, I recommend adding the pedal adapter to your order. It helps with installation. These are how the pedals come. We just order generic 3-pin scooter pedals, whatever. So if you already have a 3-pin pedal already installed in a car because you tried to install a different controller and it failed or didn't perform very well and want to upgrade, you shouldn't need a new pedal. All right, with the pedal, it comes with a connector on it. I just pull those pins out. I've shown this in other videos, so if you've already watched those, I'm sorry. I have the connector pulled off the pedal, and what I do is I put a little bit of heat shrink on each of the 3 pins to protect them from shorting to each other once they're in the terminal block. So where these go, you want to connect the green to the T input. You want to connect the red to 3.3 volts and the black to B negative. So there we go. Let's plug it in and check if our pedal works. We need direction. So now I'm going to push the plunger switch. I'm going to push this pedal. And there we go. Pedal works. Let's finish. All I'm going to do, pull this off. And in this wire harness, we had already figured out that we have to connect the white to the red. I'm going to cut all 3 of these. I'm going to just leave the orange and not use it. I'm going to take the wire strippers, strip these back. I'm gonna grab a butt splice. Got a butt splice, and this is a 14 to 16 gauge one. Splice that together. Pedal should just work. Forward and reverse, both good. I don't need these wires in here anymore, so I'm going to cut those out before they get connected to something on accident and short something. That's it. For installing the variable pedal, you have to take this out, disassemble this. I line this up where it looks good, and then I kind of trace that out. cut a bigger hole as needed with a Dremel tool. And then here's the plunger switch. I have a pretty detailed video on installing variable pedal on the first version of the speed controller. So go watch that YouTube video. I'm not going to go through it again here. Quick overview. What we have: variable speed pedal going into throttle 3.3 and B negative. I have power coming in, 2 motors. So if this motor wasn't failed, I'd hook it up and show you. I have the original 12 volt output, 12 volt battery input coming from the speed controller, looping into the shifter and out of the shifter into here. Now, there's one other way that you can connect direction. Over here, we have forward high, forward low, and reverse. These have to get connected to battery negative. So let's say you had a different kind of car, has a controller of some kind already in it. So on these are double pole, double throw switches. So what that means is there's 2 poles, pole 1, pole 2, and then double throw. So this is 1 pole, or 1 throw, the second throw. So you can connect this contact to this contact, or this contact to this contact. So this middle contact you'd connect to battery negative, and then this one you'd go to forward high, and this one you'd go to forward low. And as you switch it, you'd be connecting the battery negative terminal to forward high or forward low. And that will detect direction over here, forward high, forward low. That's the other method of direction detection. Most people have Power Wheel style without some kind of factory controller, so that's why I made this option. It's very simple. Most people get it first try. All right, that's it for installing this controller. If you have any questions, reach out to us, leave a comment on the YouTube channel. You can send us an email, contact us through Facebook. We're usually pretty quick to respond. So that's it for this video. This is how you wire up this speed controller for most uses. It's up to you. It's your DIY project. Kind of figure out how you want to do it and how you want to use it. And that's what we like to see. We like to see everyone's unique use cases. If you want to see more videos, we'll have a Lightning McQueen upgrade video showing how to install what we find to be the most reliable motors, and what we're testing a gearbox configuration, hoping that we can get a lot of life out of a stock gearbox by inserting some bearings in strategic locations. So if you like that kind of stuff, please subscribe. See you in the next video.